So yeah, thank you. At first, I want to thanks to be here and to be invited. It's the first time we're in this community, so we're a bit a new kid on the block for the spectrum scale community. My name is Oliver Gappa. I'm sales director for Western Europe in the broadcast and media division of Rohde Schwarz. So you might ask yourself, what the heck is Rohde Schwarz, maybe? Because you're not so much working with us. So we're a large German group, being funded 1933 in Munich. Many know us maybe from the university time when playing around with network testers, with testers in general, or with test and measurement equipment, because that's where the roots are, together with RF technology. We're today a global presence of around 60 subsidiaries in 70 countries. We are available. We do with 11,000 people, roughly 2 billion. This year we plan to do 2.5 billion. So we're not a small company, and we are organized in business fields. So there's a test and measurement, which is kind of the base where we're coming from. It's 50% of our turnover, and we're one of the biggest one in high frequency. We are the #1 worldwide in test and measurement. Then broadcast and media. Our biggest income stream is still transmitters in this region, but we're doing also servers, broadcast studios, encoding systems, and storage for the media industry. Then we have secure communications, also big branch. Cybersecurity, which is a new kind of step we're investing in. So within the last 5 years, we bought 6 new companies, brought them in with 500 people, and the goal is to have the biggest cybersecurity company in Europe being established. And then finally, radio monitoring, radio location, which is all going a bit more also into defense systems and so on. So that is mainly our business objectives. The one thing, because many people are coming here from high performance computing background, I want to show that is one of our later products they might be affected with soon when they go through an airport. It's a body scanner. Otherwise, this is a high performance computing attempt because there's 3,000 radio emitters and receivers in each panel, and we're taking thousands of rays at the same time to look what is, let me say, close to your skin. It's going 3 centimeters within the skin without DNA modification. So it's no risk, it's no X-ray. It's much lower energy radiation. And then this is coming back. And if we're simply living, the analysis is simply living from sheer computer power. As more power we're having, as faster we are. So we have currently prototypes running that do 3 persons at the same time running through. That will come a bit of the future we have in airports. So at the moment we stand in stuffy cabins. This is from an US corp, this is our competitor. Our ones are just walls, but pretty soon these walls will be integrated just in the building you run through, and you're scanned and you're done. And this is done with tons of NVIDIA GPUs at the moment. And it's a pretty nice supercomputer applications, because we need quite teraflops of performance for that. But coming back to what I want to talk about. So when we entered this community, and we do storage for quite a while, because media is always associated to storage. I think we are the wasters of the bandwidth of the world, more or less. Or let me say all the private people that do their home videos and waste all the storage that's available. Well, it's more than 2/3 of the storage of the world is used for media, to archive media or to transport media around. And but we have issues, so it's not so easy. And we're a company, let me say, that is not only addicted. We're not a pure IT or storage company. We always saw ourselves as a media company, so we want to offer solutions which are done dedicated for this market. And what I want to look now is a bit the master control chain. So this is a room every broadcaster has. It's finally where a lot of people look on many, many monitors. That is what is coming on air. It's checked still by humans. It's not so easy to do this with robots. So we can do a lot, but there will be always some humans being addicted to this. And where could we find us? So what we offer today is mostly the video servers doing this and the central storage. It also depends on other automation controls, on routers, and audio de-embedders, on mixes and other stuff. But let's concentrate on the central storage and the video servers in this. This is just a smaller sample. or this, it's video servers, it's some storages we produce by ourselves, and it's IP equipment, switches, and so on, which is pretty normal on this. So what's our problem? It is a redundancy issue. It's not that the industry doesn't offer redundancy. Redundancy is mostly offered in most of the file systems that are on the market. Even on hardware level, it's offered, but it's not sufficient for our application. So the standard configuration, what does it deliver? It has data replication, by single file system. There's a controller redundancy. There's a hardware failover design typically available. And then there are failover scenarios. So one thing is failing. The failover takes some time to happen. And this is a problem. So why is it a problem? We're working in media industry with protocols, partly old protocols, and everything is brand new and splendid. So within the IP world, at the moment, a lot of things are changing. The classical old baseband is disappearing and is all replaced by IP, at least in the next years. So we have tons of new SMPTE norms to know now. It started with 22.22/6 and others, and now it's 2110, which everybody's saying, hooray, we just had an AB last week in LA. In Las Vegas, not LA, in Las Vegas. And so still I'm suffering from it, sorry. So I'm recovering a bit. But many of the protocols behind are still pretty old. So VDCP is coming from Audetics and so on. It's a 30-year-old story. And this is still the automation protocol being used in playout. And it's a serial communication. It conforms on an OC model from 1978. Yeah. And it's only aware of the next clip in the queue. So it's not reaching very wide. So what it knows from all the clips being shown, it just knows the next one. So, but modern socket-based protocols behave pretty similar. So it's not that it went also for so much better and so much more clever. So and here comes the issue, and if the next clip is shorter than failover time, it results in black on air. Yeah, so, and we need some seconds. So buffering is here not a solution, since clips may be shorter than the failover time. So, and whatever we got in our fingers and tested from various manufacturers, they all needed much longer. So the average was between 80 and 30 seconds in shortest time. This is fully unacceptable. Why is it a problem? Yeah. So we don't like it, but this is not the problem. It's expensive. That's the issue. So, and why is it expensive? Because the broadcasters live from advertising. Yeah. Here just a few costs from Germany. So private broadcasters after 8 p.m. So best per time, 30 seconds at 30,000 euros. Okay, this is affordable. This is just 2,000 euros per second. So, which means a failover is not so critical if it takes 30 seconds, or is it? So, advertising Sunday afternoon Formula One, that becomes a bit more expensive now. It's 150,000 euros we're talking about. So the financial director starts getting a bit grumpy, if things happening. So, and it's 5,000 euros per second. Yeah. Whereas movies in Germany are pretty inexpensive. So, but now comes it where it gets expensive. So, very expensive Super Bowl final. So, what is a Super Bowl final? 30 seconds are 5 million US. So, this is just one. Let me say the master room is having a problem with the master signal in a failover scenario. This is by 50, by 100. So we are already talking about tons of costs. So here we come to $166,667 per second, or $5,556 per frame. We're not showing, which is horrendous, and it gets worse and worse. So it's just the costs are increasing over time. This is just what the main advertising time has cost and risen up over the last years. I just want to make sensible, so things where the IT industry could live with, because a minute in an HPC cluster isn't critical, could be very costly in the media world. So, so what do we want? So requirements. We want a non-disruptive data access during a failover. Yes, with guaranteed bandwidth during any failover event. with guaranteed max latency during the failover and with guaranteed performance in discrete mode. Yeah? And as said before, we couldn't find this on the market because whatever we tested was between 30 and 60. On the storage side, between 80 and 30 seconds. So that couldn't be the answer. So what have we done? We said we have to write something. We have to write an additional layer. And that is what RSR, where the complete thing started with, where VSR started with. This is this virtual application layer we have on our machines, and that start talking to multiple file systems at the same time. So whatever the application does, if it either reads data or writes data, we can replicate this multiple times. So we can talk in parallel to multiple file systems. If now one of the file systems is dying, it doesn't matter. We ignore it. We simply take the answer from the fastest one. So if here's an interruption, no failover process is necessary in this case. We're not relying on the hardware here because we read multiple data streams coming from parallel file systems being in sync. And that is the second thing. So it's not only that we have this virtualization layer on one, there's also a daemon that have to be installed on multiple instances, taking care that the data is in sync. So it's in de facto, it's two applications. This is a complete diagram. It's a bit complicated because one thing I learned here was a bit difficult to read, especially when you write very small. So if I'm coming next year, I do only big graphics, I promise. Yeah, easy to read, or I talk a bit more. So the thing is relatively simple. There's a storage management daemon at one side, and he's also taking care that the file systems are in sync. So we have multiple instances. For instance, Venice is our video server, we see, and this could talk to multiple storages at the same time. A daemon takes care that the data A and data B is the same. It's reading out. Both are arriving, but the application is then skipping one of the data. It needs only one to arrive, and it's always taking the first one arriving. And then the others could die. We can have this as at n+1. Which means we can have this with 1, 2, or 3. And so we never have any more issues with failover scenarios in this case. Each of the hardware blocks, for sure, could be redundant within. And we have multiple servers for full redundancy. We have also multiple servers playing out the same signal. So in these circumstances, we never go black. This is then a bit more how this looks like in a classical storage diagram. As it is, we have native file systems, we have existing clients. Venice is, as I said, our flavor of a playout server, could be other vendors as well. We have the abstraction layer, both are connected to two main storages. There's also a nearline, and there's file management replication automatically going on. And that was, it's all in correspondence to typically a MEM system. And that is, let me say, one of our first flavors where we said, here we can bring an impact towards the community, and we can develop something that makes, because we only have implemented it for spectrum scale as being the file system playing, because more and more broadcasters, this is a broadcast application, and especially the broadcaster are pushing more and more into a complete IP all over strategy. It's not only that they're going on the cables, on the, let me say, media cables itself to IP, because baseband is dying everywhere. It is, they want to have everything on the same technology, typically 25G at the moment. This is their beloved story. So 100 split it in 4 times 25 will be on the media side. Again, a little bit different to other, where they're on 40 potentially at the moment, yeah, or 100 on very fast nodes. The media industry might be a little bit different. But this is it, what companies like us have to deliver more or less. It is the fitting of the application or the speciality of the market into a generic IT environment. And for us, we have chosen IBM because it was the best we could find. I know 5 minutes because I have a timer running for myself. It was beeping here already. But to be honest, I'm already done. Because I respect that maybe somebody wants to have a question or so on and don't want to overdo it. Don't know how timely the schedule is or how timed. So is Is there any potential question?
Any question?
No?
Are you going to be providing this only for broadcasters?
Oh no, it could be used for any. So at the moment, it started, or our engagement with IBM, we have an OEM contract now, started from the broadcast and media division, but we can use this in any application. So which means for sure that will also happen sooner or later in our defense and other storage appliances.
Okay, but what you would be providing is it either going to be the software layer or let's say two appliances at the top?
Software.
Is it then
software? So it's also when you see one big trend in the media industry at the moment is virtualization. So which means all our new servers are Linux based, so CentOS. And at the moment, we still sell them with the hardware because we have built our own IP boards. We didn't trust so much the standard industry. And one of the other issues we could talk, for instance, is latency in media, which is most critical. And with our I/O boards, which are looking like a network card, but that it isn't, we have more control about this. We don't need the CPUs to unpack the data streams from it. We all do it within FPGAs directly, very low latency. So the rest is a bloody Dell server. Or not bloody, sorry, it's a Dell server.
Oliver, I know the answer myself, but maybe for the benefit of others, do you want to explain why you use spectrum scale and IP and not what people do in the past with fiber channel, all about 4K and 8K movies and frame rates and gigabytes per second and all that?
This is now a very, very wide spectrum we're opening. So one of the things, as I said, the industry loves IP and doesn't love too much other infrastructures. In supercomputing, we find with InfiniBand the second one. It's only partly so the Isilon EMC thing available in the media industry, but the principal idea is to have one single network, which is all the same. This is a principal driver of IP technology. And what we could see over the last 10 years is a permanent decline in spends for specialized people and specialized technologies. So when we're talking about off-the-shelf hardware in total, we want to use, let me say, server chassis from the market and bring our application to it by software. And then we want to have a simple connectivity. Fiber channel, which was a dominating thing for a long time, was the first one offering high data rates, secure high data rates, deterministic, SCSI protocol, but needed always specialists and needed fiber channel infrastructure. Fiber channel infrastructure is now only driven by one manufacturer, two, but is one really developing something, even this, where we are stuck in there, 32 gig, where we're talking about networks in 70, about 400. So it's one against 100 or 1,000 companies. It can't be one. So I don't see a continuation there because it's not enough industry behind it. The industry don't want a second layer of technology in their facilities. They don't want to pay for single specialists just for this low amount. And it is like always, I'm doing a lot of symposiums about IP technology in broadcast and why this is coming. It's not always the question is better. At the moment, it's even more expensive. It would be cheaper to be at the moment in baseband because it's a very developed thing and everybody knows it's working. But long term, we have to see, so how many certified media engineers we have worldwide? What do you think? 60,000. That's it. So how many certified Cisco engineers are available in Europe? 2 million. So it's a completely different subject in terms of talent and people being available. There's a big driver for IP, exchangeability on one side. On the other is, yes, for sure. Maybe you want to hear, but from the NASs we tested, then spectrum scale was by far the fastest. And this is a big chunk of the decision as well for standing here and for talking about it and using it in our further products, because we couldn't reach a lot of things with SANs in the past. So Quantum, for instance, always promised single namespace and other things they never managed to do. Spectrum scale has this for a long, long time. So it fulfills a lot of requirements the media industry needs. And recently also the speed is there. So why not? So I think the time is now done. So, and yeah, I hope it was a little bit informative for you guys. Thanks for coming.
Thank you.